Again, end behavior means you're describing the behavior of the ends of your graph. Okay, so the ends of the graph. So this really is saying as x approaches infinity, that is saying x approaches forever to the right. That's really saying what's going on the right side of your graph. Well, here's the right side of my graph. And that means f of x, which is my red graph, is approaching positive infinity. It's going forever up. Forever up, we assimilate with positive infinity. Then we always do what's happening on the left side of the graph. So as x approaches negative infinity, which my negative infinity just means my left-hand side, f of x is also going up towards infinity. All right, so this part means left and right. This part means left and right. So this is my right side here. What's going on the right side of my graph? It's either going up or down. Infinity means up. And then x approaches negative infinity really means what's going on the left side of my graph. And that means it's also going up. Right? So we're just describing the behavior of the ends of my graph. So you don't need to have all this highlighting, but you do need to have the end behavior. This is what the end behavior is. If I ask for you to write it, that's what this is. Okay, so let's keep going. If I have an example where that's negative, I'm going to have a graph that looks like this. And let's just say the example is y equals negative x squared. So this means I have a negative leading coefficient. My number in front is a negative, but still I'm in the even degree column. So an even degree of 2. So my leading coefficient, my LC, is equal to -1. Remember, there can be a pretend 1 there. And the degree is 2. All right, so that graph would look something like this. That's what that graph is going to look like. And so for the end behavior, if I'm describing the end behavior, remember, it's always going to start like this. We always are going to have as x approaches infinity, f of x, f of x approaches. This part is always going to stay. We just fill in the answer here. F of x approaches what? Where does my graph? So that's always going to stay. And so we just need to fill this last part out. So f of x approaches blank. And in this blank, I'm either going to put negative or positive infinity. Well, let's look at what that's saying. As x approaches positive infinity, so remember my x-axis is this way. So as it approaches positive infinity, which is my right-hand side, that just is saying as my right-hand side of my graph is the end behavior of the right-hand side. Well, the end of this graph is going this way down. Forever down is to negative infinity. Okay. Now I need to do the left-hand side of this graph. As x approaches negative infinity, f of x approaches. Again, this part is always the same. Every single problem we do, this part's the same. What's going to be different from each problem is your actual answer of where does that graph go. So this is saying as x approaches negative infinity, well, that's saying what's going on the left-hand side of my graph. Here's my left-hand side. Well, my graph is also going down towards negative infinity. Okay, so that's my end behavior for this type of problem. So every time we see a graph like this, it'll be looking like that. All right, and I'm going to show you a shortcut now to know how to remember this. I don't expect you to memorize this, but I'm going to show you a shortcut here in the next video that will really help you decide what's going on without needing a graph.